Hello everyone, this is Vinay here from Learn Coding with Vinay. In this video, we are going to look into the constraint, row level and table level constraint. We already saw column level constraint in previous video, and I will attach the link of that video into the description of this video and comment section as well. Right. So what are row level or table level constraints? So they are mostly known as primary key, foreign key, and unique key. Right. And why are they called so row level or table level? Because previously we saw column level constraint, those were only specific to a one column value, while this constraint will span across the rows of tables. Right. So that is the reason sometimes it is called as row or table level constraint also. Right. And also in this video we will look into the practical examples, good and bad practices, some of the tips and interview questions related to primary key, foreign key, and unique key. So stay tuned and enjoy the video. Now first of all, what are these keys? Primary key, foreign key, and unique key. Right. So primary key is a key that uniquely identifies a row in a table. Right. What is a foreign key? Foreign key is actually a primary key of another table. So basically foreign key is used to establish relationship between two database tables. Right. The next one is unique key. Now what is unique key? Unique key is as good as your primary key, but the difference is it will allow one null, and if there is a primary key already in the table and you still want you still want to define uniqueness using another column, then you will have to define other keys as a unique key, because we can only have one primary key in a database table. So let's understand with example. you know so here I have created a table called department, and in that table we have two columns, department id and department name. Department id is marked as integer identity and primary key, and department name is marked as nvarchar 50, not null and unique. Right. Let me go ahead and create this table. So it got created. Now most of the time in your project, or as per my experience, your primary keys will be either marked as a running number, identity, sequence, or guids in MS SQL. Right. So they will be either a running number used by using an identity attribute, or sequence. Right. So let me move to another table now, next table. Right. So this is kind of primary key table, or we can also say parent table. Right. Now we are going to create employee table. And now what do we have in employee table? We have employee ID, again primary key, integer identity as a primary key, employee name, department id. Right. So here department id is actually a primary key of department table, right, because every employee must belong to at least one department. Right. That's what and that's how the relationship is established over here. Right. Now we can define for foreign key two ways. First one, we can define directly with the column definition itself, like department id integer not null, foreign key, then specify the name, and then references. Look at that, it is dependent on another table's primary key. Right. So that's why foreign key creates relationship between two tables. Here it is department and employees. Right. I'm going to comment out this, and this is another way of defining your foreign key. Just the difference is, after immediate column we are writing the constraint, we are giving the constraint name. Over here we were not specifying constraint name, so it would have picked the automatic naming convention used by MS SQL. Right. But over here we are giving it a name, meaningful name. Right. And then remaining almost stuff remain the same: foreign key, name of the key, references, department, and the key and the primary key of the department table, right, which is department id. Right. And one key thing to notice over here is that here we are marking department id as not null, because every employee should have the department. That's what our business logic says. Right. This is one thing. So one example where foreign key is marked not null. Now the next column is manager id. It is marked as null, and it refers to the primary key of itself only. Right. So it refers to the employee id. See over here, it references employee table and employee id. Right. But here we have allowed it null, right, because there can be an employee who is reporting to nobody, right? So ideally manager ID column should allow null. Right, so that's why it is designed in this way. So here we have covered a very important concept of foreign key, that you need to understand your project domain, you need to understand your business, that what should be null and what should not be null. So over here we have defined department ID, which is a foreign key but not null, and manager ID, again it is a foreign key, but this time it is null, so it will allow null. So we'll see the example of data, so we'll understand it better. So let's move ahead. So let me create this table. So it got created. So let me put down some values in department table first, right? So we have few departments and 4 rows, then we have few rows, employees rows. So let me explain it, that Elias Smith, right, who is employee number, who is an employee who belongs to department 1, so basically human resource, right? And he reports to nobody, right? So that's why manager ID is null. Now next one is the Bob Johnson. Now Bob Johnson belongs to department ID 2 and he reports to employee 1, which is which will be Elias Smith, right? Similar way, if we move ahead, Diana Prince, it reports to sorry, it is she belongs to the department number 3, which will be sales, and reports to nobody, so this is null over here, right? So let me put down the data into employee table as well, right? Now if we go ahead and run this both, so we have data in department table also and we have data in employee table also. Now this department table and employee table are connected with each other with foreign key, because department ID in employee table refers to the actually department ID of the department table. So that's what the definition says. That's what we have created. Now let's try to see, some exception scenarios. So take this example. Here we are trying to insert an employee whose department ID is actually 10. So basically it does not exist in the department table, because in department table we have only 4 rows at this moment, right? So if I try to insert a department, a record with a department that does not exist in our primary key table, then this will fail. Right? This fails. Similarly, next example, if I try to insert a data where foreign key is, here we are violated the rule for manager ID, because it is 10. Again, we don't have 10 number employee over here, so this will also fail, saying that constraint violated. Insert statement conflicted with the foreign key, same table constraint, so and so, name of the constraint, and the conflict occur in the database name and the table name, and it clearly gives us the message what's wrong. Right. Now let me try this one more example. Here we are trying to insert department as null. Employee is there, department we are passing null, and we are passing manager ID also. Let's see what happens. It also fails. Why? Because we have marked, if you remember, we have marked department ID as foreign key but as not null, right? So if we try to push null value in the foreign key that does not accept null, then it will fail. If we try to insert the foreign key with null value which allows null, then it will allow the record insertion. We already saw this example over here, right, for the manager ID, because manager ID column is marked as a foreign key but it allows null, right? So let's again take a look at what do we have in the tables. So we have 4 records in the department table, we have few, I think 5, yeah, 5 record in the employee table, right? And now they are connected with each other using primary key and foreign key. Now let's take another example. Let's try to delete a record from parent table, basically department table. Let's see what is happening. If I try to go ahead and delete this, see what is happening. It generates the error. It says that the delete statement conflicted with the reference constraint name in the database this, table this, and column department ID. So what does it say actually? It says that you are trying to delete a record from the parent or primary key table, but that data exists in the another table, right? So it did not allow to delete us. Why? Because we have employee associated with department 1. See over here we have Elias Smith with department ID 1. Right. If we try to delete primary key data or parent key data that does not exist in the child table, then it will allow us to delete. For example, let's say if I go ahead and run this, what do we have in table? We have 4 departments, 1, 2, 3 and 4, right? And we have few employees, but none of the employee belong to department ID 4, right? So if I go ahead and delete the department ID with 4 from the parent table, basically from the department table, it will allow to delete. Let's see, it allowed us to delete the record. See, so this is a default behavior actually. So whenever tables are connected using primary key and foreign key, if we try to delete data from primary key and if that data exists in the child table, it will not allow us to delete, right? It will generate an error saying that violation of constraint, right? And if we try to delete a data in the primary table or parent table that does not exist, that is not referred by the foreign key table anywhere, right, then it will allow us to delete the data. That's what we saw in this example, right? So now let's move to let's move to the next example where we want to actually delete. If I delete the primary key data, then it should also delete all foreign key data, right? So how to achieve that? So this is an interview question again. You will be asked in interview, then what is on delete, uh, what is cascade on delete and update cascade delete and cascade update, right? So let's take an example of it. So let me redesign this employee table. Let me delete this employee table, basically drop it. Right. So I have the similar definition. Only thing over here I am defining that while department ID is a foreign key, but this one sentence I have added that says on delete cascade. That means if parent record is deleted from department table, its corresponding child data from employee table will also be deleted. Right. So let's see an example of this. Let me go ahead and run this. Let me create this first. So it got created. Let me put down some data. Okay. And now let me go ahead and first see what do we have. So we have some data in department table and employee table. So if I try to delete record department with ID 1, it should delete employee with one department ID also. So in this case, if I try to delete this record department ID 1, then it will also automatically delete the employee 1 data as well, because we have department ID as 1 over here. So let me go ahead and do this. So let me delete this. It says one row. See the message, it says one row affected, right? But let's see what is happening. See, department ID 1 is gone, and at the same time employee 1 is also gone because it has the department ID as 1, right? So on delete cascade, what it does, if your primary key table data is deleted, and then the corresponding foreign key data will also be deleted from another table, right? So here, one thing to note over here, that you need to be very cautious while using on delete cascade, right? Because it results in loss of data, and the message, it says that it's one row deleted, but actually it deleted two rows, one from the department and one from the employee, right? So make a wise use of it. I personally suggest to stay away with on delete cascade, and instead what we should be doing, if you have any master data, right, and if some master data over a time of period, you don't want some master data into the consideration of your project, right? So rather than physically delete it, right, we should implement logical delete. Right? So let's take an example over here. I have just kept the definition over here. Just look at this. It is the same table. It is the same table, department ID and department, but with one extra column that says is active. Now is active at 1 indicates the record is active, and is active 0 will indicate that record is inactive. So rather than deleting it physically, we are just marking it logically that okay, now this record is not should not be into the consideration. And then in your every project query, you should include in your where that says that you are eliminating the inactive records. You are only considering active records, which is active column is equal to 1. So this is a nice way to handle such scenarios, right? So as I said, stay away with on delete cascade. Implement some other logic like this. Have a logical delete column, right? Now let's take an example of on update example, right? So now before we move to on update example, since we have department table which has a number as a primary key and that too identity. So when we declare a column with identity and number, that that means that we can't actually insert the value of id or even update the value of id, right? Because that's what the identity column is. That's why the identity column is used for. The responsibility of generating data for id column is given to the database server itself. So we can't insert it and we can't even update as well. If you have noticed, if I go up, if we see the insert example of the department table, we have not specified id. They were generated automatically, right? So let's try to update one of the id of department table to something. So here I am trying to update the department id 3 to department id 5, or maybe let's say 4, anything. Let's see what's happened. See, it generates error, says cannot update identity column department id. So basically we can't update and at the same time insert when id column data, because it is marked as identity, right? So with this example we won't be able to have an example of on update cascade, right? So let's take another example over here. So let's consider we have a table called state. Now where what do we have? We have state code and state name, right? State code again we have marked as primary, state name we have marked as unique, right? So let me go ahead and run this. So this got created, right? Now another, now we are creating employee states table where actually state code refers to the primary key of the states table. Just read this line, that state code varchar 10 not null foreign key reference is state table and the column which it refers to is the state code. And here we are specifying on update cascade. So on update cascade, we'll see what it does, right? So let me create this table also. Now let me put down some values in both of the table, right? So let's see what do we have first in these two tables. And so we have state table and we have employee state table. Now employee state table and state table are connected with each other using primary key and foreign key, right? Because state code from employee state table is connected with state code from state table, right? Because one is the primary key and one is the foreign key. Now let's take an example, where there is a need to update the state codes as three alphabet state codes. Currently I have used state code with two alphabets, like for Gujarat it is GJ, Maharashtra it is MH, Madhya Pradesh MP, right? So let's make it a three alphabet letter, then see what is happening over here. So if I go ahead and update the parent table DBO state, where I am updating the state code as Guj 3 alphabet now, where Gujarat. So let me see what will happen over here. If I go ahead and run this, see again it says only one row affected. But if I go ahead and run this, if we see what data we have, then see this Guj, Guj, Guj. It got updated in the parent table as well, and it got updated automatically in the child table as well, right? So on update cascade, if the primary key in the primary table getting changed, then the ripple effect of it will happen in the child table also, and the all data will also updated. Consecutive all data will be updated also, right? So this is a very important interview question, on delete cascade and on update cascade. You will be asked whenever you go for either a database developer or a web developer or any profile that deals with database, right? So with this we have seen example of primary key and foreign key. Now let's take an example of unique key. Right. So we have already marked, if you see, we have already marked state name as unique in states table, right? So now unique key, it is similar to primary key, but it will allow one null, at least one null. Right. So let's see this by an example. So if I go ahead and run this table, let me create this table states 2. Okay. Now if I go ahead and run this, this will be inserted because this is the first row. Now this will probably fail because we are trying to insert the same row again. Now again I'm passing one more state, but this time state name I'm passing as null, and state name is actually defined as unique key that accepts null. If there was a not null, then we would have written something like this, not null over here, right? So let me go ahead and run this, and let's see what do we have in this table. Select from. Right. So we have two records. Now let me insert one more state, that is Haryana, and I am passing name as null. Then what will happen? See, it says unique key constraint violated. Why? Because it allows only one null. So we could insert one data with one null. But here we are trying to insert another record with state name as null, which will not be allowed because already one null value was there present. So basically, primary key and foreign key, they defines uniqueness across the rows, and that's why they are called row constraints. So if one value is already pushed in either in primary key or unique key, the same value cannot be used for any other row in the entire table, right? So it actually help us in defining uniqueness, right? So this is an example of unique key. Now sometime you will also see, that the uniqueness in a row is defined based on more than one column, right? So in that case, how to define that? So let's go over this, is a classic example, right? That there is a user where user ID is primary key, username is just a unique username. This can be anything, email or mobile number or anything. Email is very quite common in most of the project for usernames as a username, right? I have not taken password and other columns, just to keep the example sweet and short, just to relevant to the topic, right? So next one is, let's see this, that next one is the role table. Well, we have role ID. Again, it is marked as primary key integer and marked as identity, and role name is also unique, and see, both of them are marked as not null. So if there is a user called Vinay, right, and my email is, let's say, vinay@gmail.com, then if another record we try to insert with the same name, vinay@gmail.com, then it will fail. Similar way, role role name, let's say we have already added admin, vendor, guest, these three roles into the database table, and we want to push again the admin role into this table, then it will fail because we already have that record, right? And role name will, in ideal world, role name will never be null, so there will not be any row that has a null as a role name value, right? Because that is not a practical scenario, right? If there is a role, it has to have a name. If there is a user, that has to have a name, right? Now let's take now user role. So basically this user role is our foreign key table. These two are primary key table because over here we will have username and role ID. This user ID refers to the users table user ID column over here, this, and this role ID, it actually refers to the roles table role ID over here, roles table role ID. And so this is the primary key and foreign key example, and we also want to make sure that if a user is assigned a one role, then the same entry should not happen in the user role table. Say for example, I am Vinay admin, right? So if there is an entry that says Vinay is admin, then there should not be a second entry says Vinay is admin again, right? So it should restrict. Then how to restrict that? Then we have defined a unique key over here, that is combination of two columns, which is user ID and role ID, right? So this is an example of multiple column unique key. Right, so these are the very common scenario you will see in your project. And I hope I have tried to cover almost everything related to primary key, foreign key, and unique key. Now one more example I would like to show that whenever we create these keys, there are certain indexes created automatically. So when we create primary key, a cluster index will be created automatically on this column. When we create unique key, non-cluster index will be created. When we create foreign key, so foreign key does not create any index. So make sure whenever you are working on a performance issue, try to look around your foreign keys whether they are properly indexed or not, because these are the very common scenario that people miss to define indexes on foreign keys. Right, so let me go to our table and let me show you. Let's say, let me expand this. Let's take a look at our states table. So here we have state code as a primary key, and this one state name was our unique key. If I go to index and see, primary key created a cluster index and unique key created a non-cluster index, right? And let's take a one foreign key table also. We had employee, right? Let me go. Let me go over here. This is PK. Okay, this is not. Let me. I think it is employees. Employee states. Let me see employee states. Keys. Okay, so we have foreign key over here, right? We have primary key and foreign key. If I go ahead and extend this, then you can clearly see only one cluster index was created. There is no index related to foreign key. So basically foreign keys are very easily to be missed, to marked as index. However, they will be used most in your where and join queries, right? So remember, whenever you are working on performance issue, make sure you look out for foreign key columns and try to create index on them, right? Now let's quickly move into the differences between all these keys, right? So this will be again an interview question you will be asked often in interviews, that what are the differences between primary key, foreign key, and unique key, right? So purpose as primary key uniquely identify each row, foreign key is to establish relationship between two table, and unique key again similar to primary key, it can also use to uniquely identify each row. But if there is a need that accept, rather, not only the primary key, there are the other column also that can uniquely identify your rows, then we can only mark one as a primary key and others we can mark as a unique key, right? Now primary and unique key both allows only one value at a time, so there won't be any duplicate values. However, foreign key can have duplicate values, right? Nulls. Now by default primary key will not allow null, right? Foreign key will allow null if not specified, not null explicitly, right? And unique key will allow only one null. So this is a very important difference between these three keys, and you will be often asked question on this particular topic. So just keep in mind this one. Now number per table, basically we can define only one primary key, we can have multiple foreign keys, and we can have multiple unique key also in a single table, right? Now relationship. Now primary key does not force relationship, but foreign key forces relationship. Unique key also does not force relationship. Now primary key are often used in joins. Now this actually is not a quite much difference, I would say, because anything can be used in where and join. It's not just the keys, right? But most frequently keys will be used in where and joins, right? So we'll leave that. And we already saw at the last that if we create a primary key, then there will be a cluster index created automatically. If we create a unique key, then there will be a non-cluster created index created automatically. And if we create foreign key, it does not create automatically any index unless we specify. So foreign key, we will have to specify what index we want to create. Basically it will be a non-cluster index, right? So I hope I have tried to cover in depth or everything about primary key, foreign key, unique key, good and bad example, and interview questions also. So thanks for watching this video, and see you in the next video.